Got it.
Got it. Hey, stargazers, welcome aboard. It is the 57th edition of our online blog podcast from the Santa Barbara area's telescope and astronomy club, the SBAU Astro Hour, for the week of, what do we got going here? The 28th of March into April 3rd. And our second online meeting, general meeting, will be this Friday night with Mirek Brandt talking to us. I'm Baron Ron Herron. Proud to be the host and vice president. And yes, thumbs up for 10,000 new bookmarks will be given away at star parties and other outreach events. So our second reconvened meeting will be on Friday night. And we're meeting live out at Westmont and on the second Saturday at the Museum of Natural History, our big supporter. And let's meet the gang, shall we? The brain trust of the Santa Barbara Astronomical Unit, our beloved president in season 4, Jerry Wilson. Good morning, sir.
Good morning.
Wife is Pat Forgy. She's a supporter and certainly supports him and us. And Chuck McPartland is our outreach coordinator guy. And he sends out the notices. In fact, there's one online now. If you're a member, I guess you get it, or you can read the newsletter. Chuck is married to Pat, the merchandise manager, who made the request for some brand spanking new. I guess there's going to be a sun picture, not a galaxy on the new bookmarks, right? We're going to get 10,000 of those secretaries.
Yeah, solar images done by John Boyd, who's a club.
Aha, John Boyd. I will add him to my list. I was going to mention some people that watch us. So, Pat, thank you. You got my endorsement on that. Tom Whittemore, former Westmont College science instructor. Good morning. Now, incredible bread baker, editor of our incredible newsletter. Wife is Maureen, and there's always an interesting article in the newsletter every month from our president. Tom Totten runs the show. His wife is Suzanne. She's an artiste. And Tom, I don't know how you do it. You got me on because I came on blurry, just like my right eye is giving me these days. Bruce Murdoch is with us, shown drinking some vodka. Better get rid of that.
It's coffee.
Okay. And some of the folks that may be online, Tim turned into us is Tim Crawford, telescope maker and a big supporter, and Krissie Cook, stalwart fan of the club, and I guess our connection in some ways to the museum. Tessa Flanagan may be on board, Joe Doyle and his wife, and Jim Williams, Fred and Linda, the Ziesenheinies. They're not in the club, but they're a supporter of me, and they have collected and saved and archived every one of our 56 shows. This will be number 57. And also my next door neighbor, May O'Mahony, is probably tuned in. She's my guardian angel. Talk about Ceres, which I heard was about a third of the amount of asteroids in the belt, all in one little mini planet. From Ceres to Barnard 19, we learn about the California Nebula, shaped just like a sushi California roll out there. Visit to Bode's Galaxy and the Cigar Galaxy. I'd never heard of one of them. So Bode, we'll find out about that. And a second lion up there, a cub. Does Leo have a kid? I don't know. And Big Baba Boom, will we get a new Carrington event? Those are some of the things that Jerry sent us on his talking points email. Let me go to the funny stuff. You want to check out some of the silly cartoons, Tom Totten? And we got two from Jerry, the president, and one from Chuck. It didn't come from you, or it came from your cat? Cartoon, right?
I sent it to
Kennedy.
you.
What?
It came from Duff Kennedy, and I sent it to you.
Okay. Well, whatever he calls up, I'll just match.
All right.
Okay, that would be Don't Mess With Your Kid. It's New Zits. No, what is the name of it? From a Zits cartoon. So, stargazing boy. Yeah, Dad, have a seat. When you were just a little kid, we used to do this all the time. I know, I still remember the names of the constellations, Dad. You taught me. And they're outside on the patio checking things out. And you know that I was just, you know what? Our pictures are covering that part. Did I write it down? No, I didn't. I was going to read it off the screen, but I can't. Somebody read the last line, Dad says.
Okay, it says, you know that I was just messing with you, right? And the kid says, I always thought Orion's fanny pack sounded sketchy. So, you know, it's interesting. Jerry also sent a picture of Orion annotated and right here. And you can see that star names and distances, and there's the fanny pack down here, I guess, the Orion Nebula, Running Man. I didn't realize how big Bernard's Loop and this.
Oh, yeah.
And is this whole thing called Lambda Orionis?
No, that's
Lambda.
There's the star at the top, Lambda Orionis.
Yeah.
It's
This
just,
picture was posted on Facebook by Abdullah Al Harbi from Kuwait.
yeah. It's
Right. And the
it's
fact that this is such an excellent picture, I assume that they have wonderful skies there.
there's a mistake in the notation there. That Lambda Orionis should be up the head star, and
That's
then
right.
Colander 69 should be the big label for the big blob of red star.
Oh, okay.
Yeah.
So that got
thank
flipped
you.
somehow.
Thanks.
Are the three in the belt there somewhere?
Yeah,
Yes.
right in the middle.
Okay. And these red parts are nebulas?
Yeah,
Mm-hmm.
Okay.
fluorescing hydrogen.
Yeah.
Fluorescing
So
hydrogen.
emission.
I saw some pink on your screen one night, Chuck. You had your little laptop connected to your computer, and I've never seen pink on, a home scope. So is that what we were looking at? What we're
Yes,
seeing now?
except just the area down in the Orion Nebula.
Oh, okay. Orion's got its own nebula. Okay, thank you for sending that, Mr. President. You want to throw up Ouch or Chuck's
Okay.
cat tune? Here's
Here
the
we go.
two cats are talking. You look at the pet carrier in the corner and he says, I go in and when I come out, I'm at the vet. Then I go back in and when I come out, I'm home. The other says, could it be a wormhole?
That's pretty good.
And that's from Duff Kennedy.
Oh, all right.
That's really nice. That's a really good one.
Well, let's see. There's one other. Did you get it called Ouch? I
I
guess
don't think I
Didn't
must
get
have
it.
missed that one.
6 cartoon boxes. Henry never
I
knew
missed
what,
that
oh,
one.
Henry never knew what hit him. The monster gets out of
yeah.
it. All right.
Yeah, it's an old Gary Larson. That's an old
Oh
Gary
yeah,
Larson.
I got it. I actually have that one. Hold on, I can show that.
I remember
Just,
reading that in the Tucson paper back in the 80s, I think.
Yeah.
Been around that long? Okay, here it
Oh,
comes.
yeah. Oh, yeah.
Enlarge it, please. Thank you,
Shrink
Hal.
it.
All right.
You guys great.
A UAP is landing. Unauthorized, unidentified. What does the U stand for? Unexplained, unidentified, or unexplained aerial phenomenon. I got the AP, and there he is. Bonks, and he takes off. Okay. Never knew what hit him.
Yeah,
Da-da-da-da-da-da-da-da-da-da.
Yeah. And, Ron Larson was very popular in the Bay Area. There was a race up there called Run to the Far Side, and people would dress up in crazy outfits. It was about 7-mile run. Okay. And I think you got a free entry into the zoo.
Is
So
that right?
it was a Larson run.
I can remember after his career, he finally hung it up and said, I'm quitting. And I always wondered why, because he just ran out of ideas. I don't know, but we're all.
I heard he restarted again.
Yeah.
What'd you say, Chuck?
I heard he restarted again. He discovered, iPads and being able to do it on the computer, and actually decided he liked that. So he's restarted again, but I don't know if he does a whole lot.
Yeah.
That's called the Tom Brady Syndrome. Bruce, what were you saying about it?
I was agreeing with you.
Okay, all right.
I think he went off and did marine biology or something else that he was interested in.
Yeah. That makes sense with the zoo run.
Yeah.
Yeah, well, he loves the animals. You got talking deer and all kinds of good stuff. What are we looking at now? Top chat. Hey,
Yeah.
Baron, we saw your good buddy up at Westmont, John Palmentari. Nice man.
Yeah.
Did you see his nice lady, Tara?
Yep. She was there.
She was Lady K on my radio show for a while there, and maybe watching and listening as well. We're getting more and more. Can you tell Tom Totten how many folks are tuned in? Well, maybe it's just the beginning of the show. We might want to.
Yeah, I can only see you log into the chat at this point. Oh, it says there's 4 people watching now, and that includes me. So there's one other person out there besides Tim and Krissie.
Well, you can go on a certain, what is it, SBAU.org and watch the archived versions. There's 56 other programs.
We pick up a lot of people on the archives.
Okay.
Yeah, click on the link to YouTube stuff.
Okay. Well, welcome to a rainy Monday, and the moon's on the shrinking, waning side to thing. By this weekend, it'll be flipping over. as we head
It'll
into
be
April.
new
Yeah.
moon by the end of the week.
Yeah,
Okay.
I was going to say, Ron, this morning was the time. Of course, we love and appreciate the rain. This morning, there would have been a little tiny crescent moon just below the triad of the planets Venus, Saturn, and Mars.
Well, I assume you were out
I was
there.
looking forward to seeing it, but I'd rather see rain, to be honest. Yeah.
So you didn't get out there and get soaking wet.
It really came down.
It really did. I guess they
Yeah.
gave us warning. I had stuff that got soaked, a bunch of books sitting out in the nowhere. Let's talk about Ceres and Barnard 19 if you want. The crescent will allow us to see more. Dwarf planet in the asteroid belt. Ceres is in the western sky, best seen with a scope rather than Tom Whittemore's binoculars. He's a binoc guy. B19, is that what it is? Is that Barnard?
B19.
Yeah.
Yeah.
It's a dark splotch. First look at M41, the Pleiades.
45 is the Pleiades.
Yeah.
All right.
So, hey, Ron.
Yes.
E. Barnard was just fascinated with these dark nebulae. And I think he worked out a lick, if I'm right.
Yeah.
Up on Mount Hamilton, it's near San Jose. And he basically cataloged a ton of these things, okay, including the famous B33, which is the horse head.
Oh, that's a Barnard.
That's a Barnard. E. Barnard.
There's also a 22 at the very end of Jerry's notes. Barnard 22.
Hey, Chuck, if I'm right, didn't Barnard discover the pup star? Was he the one? To Sirius? No, he did not.
Well, it might have been. I know it was a first test with a Clark refractor.
Okay.
So it's the right time period.
Yeah. I thought he may have been the one to discover, Sirius B. The pup.
Well, are any of you focusing on the Bs or the 19s or the Barnards in that case?
Joe Doyle's pretty good with those, I know, because he has an 18-inch telescope.
Does he really? Does
Yeah.
he show star parties?
He has an obsession telescope. It's really nice.
Yeah.
Charles Schuler has a 20-inch also.
20 inches.
I think
wow.
we're going to go to the Los Flores event.
Now, is the 20-inch the front of the scope or
No,
the back?
no. It's
the
the mirror
diameter of the mirror.
The mirror in the back.
diameter.
Gotcha.
It's
All
the
right.
light collecting part.
Yeah.
So Ceres is in this because Ceres is a bright thing, and you can tell it will lead you to the B19. These dark nebula, you can't really see them. The way you see them is by the fact that there's no stars there in a region where there are a lot of background stars, but the dark nebula, and that's, I was thinking of just showing a frame of black, but here's an actual picture of the stars that you see where there's B19.
Which one is Ceres, Jerry?
What's that?
Which one would be Ceres?
Ceres is out of the image in this picture.
Yeah.
Oh, really? Oh.
This is just in where on that chart you had, the previous one, the Finder chart. This is the region, it's 10 arc minutes across. It's where the B19 is. And you see there are no stars there on this chart. Of course, if I change the limit of magnitude, then more stars will show up, but not there. You cannot actually see these nebula, except that they're outlined by stars, because nebula are either excited by a hot star and they glow red, or they're reflective nebula where light bounces off of them. The B stuff is the same nebula stuff. It's a hydrogen gas cloud, but it has no nearby illumination source. So you can only tell they're there by seeing the missing background stars. It looks like a hole in a star cloud.
Yeah.
And sometimes they're thin enough.
What, Chuck?
Sometimes they're thin enough that stars shine through from the background, but they're very red. They're very reddened by absorption from dust.
Yeah.
Have you ever
I
used
Googled
as an occulter?
Dark Nebula, and on Wikipedia, there's a wonderful graphic photograph of, you can see the whole star field, and the black nebula really stands out.
Okay, you do the occulting, Chuck. You ever use Ceres? That would be almost a guaranteed, as big as it is, right?
Yeah. No, I haven't seen an occultation with Ceres, but there have been some.
It's about what, 300 miles across?
It's 600 kilometers, I think, or maybe 600 miles. Yeah, it's good sized.
Okay. And I understand it makes up about a third of the mass of all the rocks in the asteroid belt.
Yeah.
There's also another dwarf planet called Vesta.
Yeah.
Well, I don't think it's got dwarf planet status yet, but it's a large asteroid.
Is it spherical?
No, it's kind of walnut shaped.
Oh, then that's okay. It's got to be like a billiard ball. Got to be totally round. What are we looking at here, Tom Hutton?
Food.
Ceres.
Food, glorious food. Firefox, okay. Well, before we leave the subject, my silly question of the week is, what's the main theories about the origin of the asteroid belt? They just never formed a planet other than little dwarf planets, or it was a planet that got destroyed by, let's say,
No,
Jupiter?
it's leftover debris, never formed.
All right. The thing that it's hard for me to grasp is small what, 2 meters across or 6 feet across, whatever, small rocks that got that clumped together. There's hardly any gravity there.
That's right.
You know what I'm saying? They're like boulders in space, but if it's just dust, it's not going to coagulate into a big piece of granite, is it?
Gradually, yes, but granite has been modified by high temperatures.
Yeah.
So granite would have to come from something that had been in the center of one of those blobs that had enough gravity to squish it.
But there's a theory that the rings around Saturn were a moon, right?
Yes.
Okay, that's a little different. Okay.
That was a moon that got within the Roche limit of Saturn and got torn up.
Okay, you're gonna have to explain that Roche sometime. What are we
Sure,
looking
I'll do
at
it.
here?
I mean, it's where the tidal forces overcome the strength of whatever material is holding the moon together.
Where gravity sucks.
Yeah.
But all 4 of those gas planets have rings. Does that mean they all had a moon that went bad?
Potentially.
Wow, amazing stuff. Anybody want to explain what we're looking at here for our vast audience of 4?
The larger asteroids.
So Ceres is the big one, and then Vesta, second biggest, and they're showing some smaller asteroids.
Yeah, biggest in that picture, though probably not the second biggest overall, I don't think.
Well, some stupid video I watched on YouTube told me something I didn't know. If you were to go to any asteroid, regardless of the size, you probably wouldn't see any others. They're that spaced apart.
Yep.
Okay, I always thought, it's like the movie Star Wars where they're flying in between them and around them. And
No.
not like that at all.
That is a myth. That would be like in Saturn's rings.
Yeah.
The average distance between asteroids of appreciable size is something like 1 million miles.
Yeah. You'd see asteroid, if you were on one of these asteroids, you'd see the other asteroids a little better than we see them from Earth, but they would just be very small, dim stars that moved.
And we're still finding new ones all the time, right? And naming them. And
Not me personally, but yeah, they're being discovered.
I think as far as the numbered asteroids, which have orbits determined for them, it's up over 600,000.
Is that right? All right. Jupiter had something to do with it, I'm sure. It's affecting the whole solar system. Supposedly it came in and passed us guys. That's rocky planets on the internet, and then went back out somehow. I follow that. Okay, gentlemen, shall we take it chronologically as Jerry sent them in his talking notes? What the heck is the California Nebula? Where is it? It's an astrophotographer's dream come true. We're talking Comet 19P, which is Borrelli, is fading away. It's magnitude 10. You can barely see it. Sits just south of the California Nebula, NGC 1499.
Right.
Okay, it's in Perseus, not far from where Ceres we were just looking at. You start looking just 7.8 degrees north at magnitude 3. The pair. Wait a minute here. I can't read my own writing. Attic is one of the stars. We're looking at another nebula here.
It's California.
Oh, that's the nebula.
It's
Attic is a star in the foot of Perseus.
Aha. Okay, Zeta Persei, it's also known as. And 19P is 4 degrees northeast, but it's going away, right? Borelli, 1.5 degrees southeast of NGC 1499. So how did it get the California name? Anybody know?
Turn it to about 90 degrees and it'll look like the coast of California on the left.
Including those little green numbers where the rain came down overnight.
Yeah.
California Nebula is illuminated by the nearby Z Persei to its southwest. Is that a star? Oh, look at that. We turned it.
Yes, like Chuck said, it's at the base of the Perseus.
Stretches 145.
I've seen this nebula in my 18-inch, but I need an oxygen-3 filter really to pull it out.
I was going to bring that up too. Scott Reed has a 12-inch dot that's in a ball, so he can rotate it any way he wants. And the last time probably we were up at the gun club, he showed California Nebula to me. It was wonderful. And he just took the oxygen 03 filter and just put it in front of the eyepiece so you could look through it rather than putting it on the eyepiece. But it was very visible. But it was blue, not red.
That's
oxygen 3 is a green line in oxygen.
Yeah.
Well, do we add the pink or are they colored that color?
No, this was tricky. Somebody created that.
This is an easy star to photograph because you see nebula to photograph. You see the guide star, a handy guide star right there, right next to it.
Has low.
So here's another view of the same nebula, but in infrared.
Mm-hmm.
Oh, wow.
And then Wikipedia has H alpha, just grayscale.
Yeah,
and
much more impressive.
Yeah,
what does
the
this
alpha
mean?
is the red color, even though
Jerry,
you showed a black and white one.
Jerry, what does this mean? Captured in narrowband. What's that?
Oh, they have several narrowband filters on it.
And so somebody used probably 3 different narrowband filters and then combined the image here. So it's probably picking out emissions from hydrogen and like sulfur and oxygen. And then arbitrarily assigned colors. So that's really false color.
Yeah. The human eye will not see this, right, Chuck?
Yeah.
I don't believe you gave us the distance. How many light years across are we looking at here? Just a few or hundreds or thousands?
Oh, I would guess thousands, but I don't know.
Well, it's thousands of light years away.
Yeah.
Yeah, thousands away. Yeah.
It says 1,000.
Yeah.
Okay.
1,000 light years. So
And from the dimensions there, 2.5 degrees, you could use trigonometry and figure out how many light years across it is.
Mm-hmm.
Okay. Is it a star nursery?
Doesn't look like it's dense enough.
Mm-hmm.
But
Yeah, it's 5 full moons in length.
Okay. Yeah.
oh, so like 2.5.
2.5 degrees. Yeah.
You notice how quick my lightning mathematic brain came up with that.
That was. I'm still stunned. I'm still stunned, Ron.
You miss your class. You miss your lab. I'm sure, Tom Whittemore.
A lot.
And there was a little note there that the California Nebula was seen by Barnard.
Oh,
Did he ever come to California, you suppose?
he was at
He did work in California, up at Mount Hamilton,
Mount Hamilton near
near
San Jose.
Berkeley.
Well, it says at the very end of your notes, Jerry, however, California Nebula has low surface brightness, so you guys probably wouldn't be able to see it much in your telescopes. You'd need a Hubble shot.
Well,
No, you can. Bruce was just describing seeing it when an 18-inch or 20-inch?
12-inch.
12-inch,
Really?
okay.
12-inch.
As good as
Yeah,
what we
you get a dark sky, you can see it, but it's not going to stand out because it does have a low surface brightness.
Huh.
Because
The
it's
telescope, I think, was an f3.9, so you do get a nice big wide field of view.
So Ron, when I was teaching at Evergreen Valley College, I got a chance to take my students up and look through the 36-inch refractor. So we all got a nice look one night. Beautiful scope.
Where is at the other school? That's not the Westmont scope.
Oh, no, this is Bay Area. So Mount Hamilton houses Lick Observatory.
Wow.
It's near San Jose, actually, not Berkeley.
Not at all. It's up above San Jose. You can see San Jose. I've been up there many, many, many times. So
Well, that leaves us with a great opportunity to plug our, what is it, third Friday of the month? We've already done one live and we're going to continue, I guess, in April at
Yeah, we
Westmont.
have third Friday of the month at Westmont, and second Saturday will be the first one at the Museum of Natural History. And they both have observatories.
Yeah.
And at the Museum of Natural History, it's a 20-inch scope, and at Westmont, it's a 24-inch scope.
And it's a setup like star parties. Everybody brings their own little scopes.
Yes,
the club,
also.
our club does downstairs.
Yeah.
And Tom has uses an 8-inch. Tom Totten uses an 8-inch Schmidt Cassegrain on the deck.
In my experience is you kind of take a little curving stairway to get to the second level of that observatory, and there's Tom Totten's cookies.
Yeah.
In any event, great stuff. Let's go to Bodie's Galaxy and the Cigar Galaxy. You want to talk about that, gentlemen? You gaze north toward Ursa Major and the Big Dipper, and there's two galaxies in the northwest part of the Great Bear, which is M. My eyes
81 and 82.
81 and 82.
Okay, so Bode's Galaxy, is it pronounced Bode or Bodie or Bode?
Bode.
Bode.
Bode, I think he was German, Bode.
And then there's a cigar. How about a cigar? Let's see here. M81 discovered in 1774 by
Bode's Galaxy is on the left here, and the Cigar Galaxy is on the right. And you can see the active core of the Cigar Galaxy.
It's getting tidally disrupted by M81, which is like the 500-pound gorilla.
Yeah.
And so it's a starburst galaxy. There's lots of supernovas, and it's loud in X-rays and loud in infrared.
Yeah, often called a Seaford Galaxy.
Now,
Hey, Bruce,
these are
Bruce, which galaxy had the supernova that you photographed?
M82.
Cigar.
82.
Cigar.
the one on the right.
And you see kind of
Right, that one.
to the left, there's two fairly bright stars, and there's like almost like three in a line on the cigar. But just to the left of the cigar. Those two there, they kind of pointed to where the supernova was inside the galaxy. So it showed up quite well.
Right. One of my students imaged it through the 24-inch at Westmont.
Now, these are easy objects to see in an amateur scope. In most scopes, you can get both of them in the same field of view. They're close enough together.
Yeah. Tim pulled them in on the Westmont night, Chuck. Yeah.
Despite the moon.
Yeah, despite the moon. Yeah. Tim Crawford pulled them in for the folks. It was nice.
Would it be possible
If I put the focal reducer on the 11-inch, I can and put a 20-millimeter eyepiece, I can get both of them in view.
We certainly know why one of them is the cigar. It's edge on, and it seems to be, if I'm right here, a little more distant than the other one because it's a little
they're both about 12 million light years away. But they're only like 300,000 light years apart from each other, which is comparable to their sizes. So they're interacting quite strongly, and 82 is smaller than 81. 81 is more massive, and that's why it's disrupting the other one.
82.
Are we not looking at 82 though, edge on?
Yeah.
So you don't get the full visual impact of its size.
All right, you said 300 light years apart?
300,000.
How far away from Andromeda are we?
2.5 million.
2.4 months. Oh, whatever, either one.
We're right above each other then. Okay.
Depends which edge of Andromeda you choose.
Okay, it's a big, there's two big wings, arms.
Arms.
Fascinating stuff.
Now, as long as you're up in the Ursa Major area, this is like a cornucopia of galaxies. I mean, there's a lot of galaxies up in that area.
Right.
And all these M objects, you can see the Virgo cluster off to the right. And in there, you get M101, M51. These are bright, spectacular galaxies to look at.
Well, M101 isn't all that bright, but it is nice.
Yeah.
First I saw that, Chuck. I was doing a maiden voyage on my 18-inch at Lassen. Of course, really dark skies. It was breathtaking. It was really nice. Really nice.
Yeah, it's a spectacular face-on spiral. So is M51. So
Did you say M101?
Yes, it's near the handle. See it, Ron?
Yeah, so that's one of the last that Messier found. He only has 100 and something, doesn't he?
110.
110.
Wow. You suppose that's like a local group like we are, but it's not part of our local group, but all those galaxies are pretty much part of a filament?
Oh,
Probably some of them.
yeah.
I mean, there is a, not called a local group, but they are in a group.
Yeah, I think
Probably
Ursa Major. Ursa Major group,
Yeah.
Chuck.
Uh-huh.
Now, the advantage for us is that Ursa Major is up in the sky almost every night. So it rotates around the pole star. And for mountains in my area, you can just see it under which I think is where it is now, underneath Polaris.
It's oriented, rotate this view that you're seeing here just a little bit more counterclockwise is the way it is now in the evening sky.
Right.
Yeah.
Yeah,
It looks like the Big Dipper is pouring down into the Little Dipper.
That's it. Yeah, the old saying was that in April, the Dipper points down and gives you showers.
Oh, I remember that phrase. Yeah.
Yeah.
So the Little
Just
Dipper
depends how late you look at it.
Yeah.
Or where you grow up.
Love this stuff. Just eat it up.
Yeah.
Fascinating.
Here's a Virgo cluster of galaxies Wikipedia has. You know, we make it any bigger or not. Nope, can't make it bigger there.
Yeah, you can see M81 in there outside of the local group. Kind of at the 4 o'clock position, yeah.
There it says the Ursa Major groups, Virgo cluster.
Huh. That's our group, or is it the group we're looking at up in Ursa?
It's several groups.
So there's in the Virgo clusters, ballpark, I don't know, 30, 60 million light years, something like that.
I think it's 55 million light years away.
Yeah, that sounds better. Okay.
Would it be fair to say that most of those galaxies are not moving apart from each other, but are probably closing in like our neighbor galaxies are?
Yeah, the local group is blue shifting for us.
So all this raisins expanding in the cooking loaf is going to be huge raisins, big clumps of super galaxies. A few million years,
yeah, that's
right?
the raisins
pretty well
are a
murdered
simplification.
that metaphor.
Ron, thank you. You just inspired my next loaf of bread.
Raisins.
Raisin
If it's
rye.
blue shifted, that means it's coming toward us.
Yeah.
That's right.
Yeah.
Well, I can't buy that. Are the color? Well, it just went off. So fascinating.
Oh, sorry. I go.
I guess Ron, the most famous blue shifted galaxy would be Andromeda.
Mhm.
Yeah, right.
The most famous one.
Just makes me think that at the very end of the universe, it's going to be nothing but big, giant black holes.
Possibly.
Huh?
And they will evaporate.
There's a large number of theories about what the universe will be like in the end game.
Yeah,
It all depends on whether what we call constants are really constants.
that's true too.
True.
But you would think the law of averages with all those stars we're looking at in all those galaxies, there'd be a supernova somewhere and we could see it. Wouldn't we be?
There is. Every night you can find hundreds.
Oh, yeah.
Oh, really?
There are more stars in the universe than there are grains of sand on Earth.
God, I've heard
If
that.
your telescope is big enough, Ron, you can find hundreds of supernovae every night, brand new ones.
Is that right?
Yeah,
Well, I've heard they outshine the galaxy they're in. Is that
They
possible?
that's
do.
right. That's how you see them.
Yeah.
The galaxy lights up a little bit. It gets turned on. And how long does that last? Days, months, weeks? hours?
Like a month or two for a
Okay.
really big supernova, for a core collapse supernova. I think type 1As are shorter.
Well, there must be people that just do that. Look for that all
Sure.
night. on their
Sure, there are
telescope.
supernova factories, or they call them transient factories these days.
Is that right?
Up at Lick, they have one. That's Filipenko set it up, I think.
Mhm.
Our alumnus.
Yep.
Well, if a supernova in a distant galaxy will light up brighter than the galaxy it is, if we ever get one in the Milky Way, there's going to be no night, is there?
Well,
we're going to have one. I mean, the next topic of discussion down after the Lion Cub is one we had in our galaxy.
Let's go to that.
it would have to be close to be that bright, Ron.
Oh,
And our sun will never do it.
you don't think so?
Nope.
No, I know so.
It's
Not
gonna
massive enough, Ron.
It'll expand and eat us. It'll do that. It'll become a Betelgeuse?
No, that's
Nuh-uh.
a supergiant. It'll only become an Aldebaran.
Mr. President, or any one of you, how far away from where we just were, Ursa Major, is Leo, the lion, because he has a cub, and I didn't know that.
Well, if you poke a hole in the bottom of the Big Dipper, the water runs out onto the back of Leo the lion, and on the way it gets Leo Minor.
So it's on the ecliptic. It's part of the zodiac.
Or as you can see on the finder chart for Leo Minor, it's midway between Regulus and, can't read it on this one, Merak.
Merak. Not to be confused with Mirik, our speaker on Friday night.
No.
Grant, who may be watching us incidentally. There's an asterism out there called the Sickle.
That's the head and the mane of Leo.
Yeah.
It's the head of
Tom, can you
Leo.
put up the finder chart for Leo Minor?
Is this not the one?
Well,
I
you're
haven't
not
seen
supposed
one.
to-
I don't have
You're
it
not displaying
highlighted. Okay.
anything.
I've been circling and thinking I already had it displayed. All right.
Well, incidentally, speaking of the lion, MGM just got sold to Amazon, so I'm not sure if he's going to roll
Okay.
any movies anymore.
So you may remember Regulus from the 2017 total eclipse of the sun. It was right next to the sun. If you took a picture of the solar eclipse, you could see Regulus in the background.
Mhm.
But now it's in the night sky here. And the line between, the white line between Regulus and Merak, and halfway up there is this little teeny triangle that doesn't really remind me of a lion cub, but it's little. And that's Leo Minor.
And they had to call it something.
Yeah.
Well, is it pictured on the inside of the Gladwin Planetarium? Do we have a cub up there?
Sure.
Mhm.
It's just,
No,
I was
relation.
thinking of the dog star.
Yeah.
The cub there is
The
just two
hunting dog.
stars.
That's the pup.
Now the pup.
Isn't the MGM lion called Leo?
I don't know.
I think it is. It's got sold. So the ecliptic there, asterism sickle. Did we? Oh, there it is. Ah, be darned. Baby's already got a mane.
Well, fanciful description here.
Yeah.
Little chip off the old block of his parent just below him. Fascinating stuff. That's Leo Minor.
Yeah, this is more the view you get here.
Yeah.
There's a name and I need pronunciation of Praccipua. Praccipua.
Recipe? You mean
No,
the manger?
Looks like Precipua. Precipua. Well, Tom went off of it, but
Sorry.
The bright star up there, Praccipua.
Oh.
46 Leonis Marinus.
Minoris.
Minoris.
Minoris. All right, put an I in
Need to
it.
brush up on your Latin, Ron.
Well, no,
That graphic that Tom put up of Leo, where they put the stars one on, and makes it almost look like he has glasses on.
now the lower the number in magnitude, this is a 3.3, the easier it is to see. Right?
3.8, it's almost fourth magnitude. And that's the brightest star.
Mhm.
Okay. There is no alpha star in this grouping. What does that mean? We've got to have a main star and we don't have a main star?
I guess they didn't name Elucida.
It's like the guy in charge of the office is the alpha dog. We got alpha stars.
No.
Interesting. Okay. Fascinating stuff.
Yeah.
Main stars, Leo Minor, major and minor.
It's going to say just Ron, where I studied Latin many years ago, I would say Praccipua, because we used to pronounce Latin like the Italians speak Italian.
Really?
Mm-hmm.
Were the first,
I had 4 years of Latin.
did you really? You speak it fluently? Not too many people.
I can read it pretty easily. Yeah.
Is that right?
Well, I went to a seminary, so I studied 4 years of Latin.
A lot of our words are based on Latin. I gotta tell
When
you.
I was in high school, we had 2 years of Latin, and in the second year, we were speaking Latin in class.
Mm-hmm.
They do all the Catholic masses in Latin at one time, and if you didn't speak,
Mhm.
it was a
Yeah.
problem.
Yeah.
Well, I'm going to save Big Baba Doom for the ending. We got about 20 minutes and go to a supernova of 1054. The new moon coming in April, ladies and gentlemen. Let's check out. Let's see. Charles Messier's crab. He was a crab. M1, the first of all of them. There it is. Actually discovered in 1731 by John Bevis, amateur astronomer. Messier, though, spotted it 27 years later in 1758 and began his famous catalog of non-comets.
Mm-hmm.
There's no comet with the name. Well, the comets come and go. Don't they? He must have known that, I guess.
And Ron, of course, somebody used a palette here to enhance the colors. But when I see it through a large scope, I just see like a splash of milk.
Yeah.
You know?
Looks like milk and water.
Yeah, that's right.
What bad? There's some pink in there. There's another version of it.
Yeah, just different wavelengths.
Oh, okay. But they think it blew up in 1054. They saw it back then. It got recorded, right?
It's recorded in Chinese documents.
Right.
To the date.
A
If
guest star.
Tom, if you go to the URL that's there above one of the
Okay.
one of the pictures, you'll see a graphic of the M1 over time.
Right.
Ah, okay. An animation.
Yeah.
But that's not it, actually. It's this
Yeah.
one here. Before, after, before, after, before, after.
You can see it's expanding.
Yes.
Yeah.
Yeah.
Over how many years in between
This
those?
is from 1973 to I think it's 2021.
Okay.
Wow.
So 50 years. And Ron, there's evidence that this thing was seen by the Native Americans in Chaco Canyon because there is a wall painting, okay, by the natives there in 1054 that shows a crescent moon and then this big, looks like a star, which was apparently the supernova going off.
So we get a nova average in our galaxy, what, once every 100 years?
Supernova. Supernova.
Yeah, supernova. Uh-huh.
Okay, so it's just going to keep expanding into space and never slow down, collapse back on itself?
Someday it expand so big, it's so thin, you won't even notice anything. It would just be the background dust.
Mm-hmm.
Is there a white dwarf in the middle of it?
Neutron star.
Neutrons. Oh, this
You
is
can see
a big.
For some reason, I don't get the impression neutron stars shine. Can you see neutron stars?
Yeah, you can see it in the center here. See with the ring around it?
Yeah, that's the X-ray, the one where you can see the rotation.
So neutron stars are halfway to a black hole, aren't they?
Yeah, sort of.
Sort of.
Add a little more and they totally wink out. Interesting.
Mhm.
They basically, Ron, leave behind these spinning cores that have huge magnetic fields. And so the magnetic fields basically ignite the local area. And so you can see, you actually.
But
You
just
can
like
see the jet coming out of this one in some of those images.
Yeah,
That's the X-ray image.
yeah.
There, right there. That's the X-ray image.
And this thing's rotating 33 times a second. So it's a pulsar. It beams by us like a lighthouse 33 times a second.
33 times a second. And how big is it? How far across? 10 miles or so?
It's going to be what? Large city or Earth size probably for the neutron star.
Okay, so the Earth is 24,000 miles, and that 24,000 miles gets taken in 1 second.
That's its circumference. It's about 8,000 miles in diameter.
Right.
Yeah, but I'm thinking of if it's turning 30 times a second and it's got that much surface area, that surface area is really booking. It's almost half the speed of light, wouldn't you say? Maybe.
It's moving along pretty fast.
Yeah.
Chuck,
So-
here it is. It says neutron stars have a radius of 6 miles.
Okay. I mixed up white dwarfs and neutron stars when I said Earth size.
Everything's a neutron. There are no protons and electrons. They become neutrons, right?
Predominantly
Squished
neutron.
together.
Yeah, the electrons were pushed into the protons to become neutrons.
What happens when it becomes a magnetar and it's super magnetized? Is that different?
Then it,
That's
then
just
it has
one with a stronger
magnetic
field.
That's another topic, I guess.
Yeah.
Well, as far as Crab Nebula, the only thing I was missing is a couple of pinchers, big claws. Maybe there are areas. What is this? What are we looking at?
Well,
Oh,
visually, back when what Lord Ross or Herschel or someone with the big
was
telescope
Lord
looked
Ross,
at it,
yeah.
their drawing, it looked like a crab to them, and that's where the name came from.
well, then I spoke too soon.
Photograph-
With the
don't-
60-inch
don't
Burr
reproduce that.
telescope, Lord Ross was able to see some of those red filaments that we were seeing.
Right.
I mean, they didn't look red to him, but he saw the filaments. And so he drew those and it looked to him like a bunch of crab legs.
So that's all those elements that were created during that star's life are out there in that nebula, in that gas cloud, right? You got boron and potassium and selenium.
Yep.
Everything's there ready to make new planets.
Yep. And the things that were created in the explosion, all the heavy stuff.
A first generation star would be just hydrogen blowing up, right? Or do they do that?
No, it's Ron, they don't blow up. Well, first generation star would have been mainly hydrogen, just like any star today. It was the same, except they could get a little bigger if they weren't contaminated with heavier elements.
Right? Okay, but after a second or a third generation star, then you can get an Earth with everything there on the.
No, you could, after a first generation star, it would produce those elements.
Yeah.
It
But
would.
the first generation
Yeah.
stars didn't have those elements to incorporate into their bodies when they formed.
They all start with hydrogen.
Yeah.
So this star reached the iron level, right? And
Yes.
blue,
Yeah.
which is
Well, that's as far as they can go until
Yeah.
they go
Until the
supernova.
explosion.
Right.
and then the explosion gives you in that instant the higher elements above iron, right?
Yeah.
Right,
It's
some
not
of
an
them, yeah.
instant. It's slower than that, but yeah.
No, not above hydrogen, Ron, above iron.
Yeah.
In order to blow up, that star had to have made iron in its core.
Yeah, right, yeah. An iron. Okay, what are we looking at? Great red spot.
Okay, let's move on to the Carrington event. Otherwise, we won't get time for it.
Right, Big Baba Doom. Every few centuries, sun blasts. Oh, the sun blasts out, and it's been a while, thank God. 1859, September 1st and 2nd, the telegraphs went dead, and some of the telegraph operators who were functioning back in the 1800s got electrocuted or at least shocked. They went out, and they're looking for it to happen anytime. We've had them since, but not aimed at the Earth. Is that a fair statement?
That's
Yeah,
what
well,
this,
they happen fairly often, but they just don't aim toward Earth.
yeah.
Where is Carrington? Is that a place?
That's the guy's name.
Oh, that's
Yeah.
the guy's name. 1859, and we were just barely in the electronic age,
We were in the electrical age.
electrical age. All right.
Luckily
So the-
for
Telegraph
us.
wires, not even telephone wires.
Right. And so also the sky was full of auroras as far as Columbia. You can see
Right.
them.
My God.
When I was a teenager, I was listening to the radio, the Red Blanchard show. But anyway, he was commenting the sky was pink. And I went out and looked, yeah, and the whole sky was pink. And I grew up in the Bay Area. So that had to be some sort of aurora type event.
Uh-huh.
Yeah, back in 2001, there was a coronal mass ejection and there were auroras visible here from Santa Barbara. And I happened to be up at Cachuma Lake, and I had been spending the day looking through a solar filter at the sun, watching this huge sunspot. And I'd heard about a coronal mass ejection, but it didn't connect. That evening, I started to see red stuff in the sky, and I thought, oh, wonder what's going on. Is there a brush fire, is your first thought here.
Yeah.
And then an ambulance came out, and he had his red light flashing, and I thought, oh, that's what I was seeing, because somebody had had a heart attack in the campground. And then he went away and the sky was still pinkish red. And then I connected, oh, wait a minute, there was a coronal mass ejection. And the whole sky turned pink and there were green blobs in the north moving back and forth on the horizon. And there were little violet streaks that would go up to the zenith.
Sprites.
And I went and I woke up a friend who was staying in a travel trailer there, knocked on the door, woke him up. It was about 11 o'clock in the evening. And he came out and he said he had traveled to Alaska, especially to see auroras. And here he was right at Ketchuma. There was an aurora better than he had seen going up in Alaska.
Alaska.
And then it lasted about maybe an hour and it was gone.
Well,
The
Columbia,
thing I was just discussing happened probably around 1955 up in the Bay Area.
Columbia, the country of Columbia is pretty close to the equator. It might have seen both of the auroras, the Australis from the south.
Yeah.
They almost met.
Yeah.
Ecuador.
It's pretty close.
Well, is this the same thing as a solar flare?
No.
It isn't. What's the difference?
A solar flare is like a magnetic reconnection where you get a big explosion. It may cause a coronal mass ejection, and then all that material will come and hit us. So they're sort of connected, but they're not the same thing.
But do they?
Well, isn't the mass ejection caused by when we get the big loops and they actually cross each other and they get
And that's the reconnection, and you get a big flare. Yeah.
right? Then you get the outside part gets burped off.
Yeah.
Do we get a sunspot for every one of those, or a big?
Usually they're associated with sunspots, very large ones.
Okay, a geomagnetic. What's the word? Yeah, geomagnetic storm.
That's
That's
what
when it
happens
hits
on
us.
Earth.
Yeah.
Oh, it's on when it hits us.
Yeah.
Okay, and that's
There was
the-
another Carrington event called the Miyake event in AD 774. And that was deduced from Arctic-Antarctic core samples.
But now
And we'd be really in trouble if one of these Carrington type events hits us right now, because we're so dependent on electricity, and there are some big transformers, and it's a small number, like 7 of these big, huge transformers that are used to transmit electricity across the US. And they would tend to get fried in one of these events, and they're very expensive. So nobody has spares, typical American business thinking. So it could take potentially months to years to recover from one of these things.
probably take out a lot of satellites too.
Yep.
I was just thinking, we will know in advance because optically you see the ejection before it reaches Earth. And I think I just unplug everything.
You're still here.
Well,
Yeah, we get some warning now. We have satellites up there, but could you shut down the whole grid in time is the question. And even so, there'd be induced currents in the
Well,
wires.
also the voltages that are created might be large enough to jump across the big switches that they open.
Yeah.
Arc.
Yeah.
Well, now my understanding is that anything that is on the spectrum, the electromagnetic spectrum, which are photons in various forms, radio waves or the colors, the light itself, maybe even X-rays and gamma rays, they go the speed of light. They're here in 8 minutes. But these things are particles, aren't they? And so they only go, what, 1 million miles an hour?
Yeah, they take a day or two to get here.
Yeah.
Mhm. You can
So,
see them coming.
when
We have space weather satellites that are on the watch for that. So our satellites in orbit will be at risk from the particles, which we're partially shielded from with the magnetic field of the Earth. But also the atmosphere of the Earth is susceptible to the impact and would expand and rise, and it would increase the drag on low-level satellites. We just lost a flock of starlings from that kind of effect here recently.
Well, that's
Where they
because their
re-entered
last
the
three
atmosphere.
malfunctioned, and they didn't
What's
actually
that?
reach the orbit they wanted.
Yeah, they put them in a very low orbit, a low LEO orbit, parking orbit, and then they send them from there into their assigned orbits. And they were in that parking orbit when the Earth's atmosphere expanded, and the drag increased, and they re-entered.
So our electromagnetic field, it just overpowers it. It's too much when it gets to the Earth.
Yeah, it gets pummeled.
Yeah,
That's why Columbia got to see the
There's a these are Maxwell's equations. There's an intimate relationship between moving charge and magnetism. So when the moving charge hits the magnetic field of the Earth and starts to curve around it, that's flowing electrons, and that creates more magnetic field, which induces currents on the Earth, like in telegraph wires.
So are you saying electrons?
You can see this aurora forecast here, and estimated planetary K index. You can go to spaceweather.com and actually sign up to get a text or a call if your magnetic K index in your area is above a certain amount and there's a chance of auroras. And we've had club members who have signed up for that years ago, when the sun was in its last active phase, and it's ramping up again now. And they got these phone calls at 2 a.m. and they went out like to the bridge to nowhere and set up a camera and caught auroras. So they weren't visual, but the camera could pick them up.
Wow.
That was before LED streetlights.
Yeah.
Now you have to get away from Goleta.
So the picture that shows the flare going off, but not toward Earth, that we had up there a little bit ago, that was an event that was photographed on February 15 of this year. So it's a very recent event, but it was aimed the wrong way, so we missed it.
Yeah, the sun is ramping up in activity again for heading toward another peak in like 3 years.
Yeah, about that.
Well, you would think the odds that it would hit us, I guess, every 200 years?
Well, that's extrapolating from past events, but it's not like these are on a regular schedule other than being associated with active times on the sun.
Yeah, these are like trying to predict them. It's like trying to predict earthquakes.
Okay. And the sun rotates on an axis just like the Earth. Do these things come out anywhere, like on the poles, or just from the sides, you suppose?
Well, they come out where the sunspots are, and the sunspots kind of cycle from the equators to the poles during the course of an active period.
You can see on the picture that's on the screen that there's a line of sunspots or bright spots below equator, and then there's another line above the equator. That's the solar activity coming through the surface that is moving from the equator to the poles, as Chuck just said.
Fascinating stuff.
And different parts of the sun rotate at different rates. It's like a big fluid ball, so you get all kinds of stuff going on.
And that's
why you get those eddies.
That's what twists up the magnetic field lines and gives us the 11-year solar cycle.
But the only thing it'll affect is the electronics on the planet. It won't make it hotter or anything like that.
Right. It won't affect the weather.
Okay. Or our own radiation on the skin and stuff like that. It won't come through.
Oh, well, it will probably increase radiation on aircraft at high altitude.
Uh-huh. Well, fascinating stuff, gentlemen. I got to tell you, we've reached the end of the show. It's noon, our time on the 28th of March. Friday night, we convene again online, and Tom Totten, webmaster, you're sending the word out to all the members of the club. They can watch on YouTube just like they watch this program. And some of us on the screen now will be there. And Mirek Brandt of LCO, which is Las Cumbres Observatories, headquartered in Goleta, will be our speaker. Talk about their discoveries and updates, and also more on exoplanets. So be tuned in. And then anything happening quickly, Mr. Outreach, after that?
Second Saturday at the Museum of Natural History, Star Party, third Friday, Westmont.
And we'll have another meeting out by the Palmer Observatory there.
Right, on the second Saturday, we'll have a planning meeting.
Okay, gentlemen, take care of yourselves.
Because the time has shifted, the business meeting on second Saturday will be 5:30.
Well, yeah, we can probably get away with that, but the museum has still listed the event as starting at 7.
Yeah,
we're
that's
going
the
to have
party.
the observatory open, so
I think
don't
they
know if
said
we want to
from
move
dusk.
it to 5:30.
Chuck, I think they say it starts at dusk for the star
Yeah,
parties.
well, yeah, but if you look at the email they sent out to members, They're still giving the start time as 7 p.m. So I think we might be wise to do still 4:30.
I don't know. 5:30 sounds fine. We should get it
Okay.
done.
So we'll work that out, folks, and we'll announce it.
Yeah.
Yep. Well, congratulations. Congratulations, Mrs. McPartland, for getting your 10,000 new bookmarks, and Krissie Cook will take care of you and the rest of you. Tell your friends about us. We've been here over a year. Number 59 will probably be next week. I'll see you then. See you first Friday night for Merrick's speech, and thank you very much. Take care of yourself. Don't catch BA2, please.
Bye.
See ya.
Thanks, Baron.